we lost a couple people.
No gain.
No gains.
No
No gains there. Alrighty, here we go. Starting into your first ever lesson when it comes to trigonometry. This is exciting stuff. So we're going to talk about angles and their measurements. So to talk about trig, we got to talk about angles first. Okay, can't even get to the other stuff until we figure out this. So our objectives, and these are relatively small things that we're going to cover here. So find degree and radian measure. We'll talk about those. Determine what coterminal angles are. Arc length of a sector of a circle. Compute linear and angular speeds, and then compute the area of a sector of a circle. Okay. So the nice part about this is even if you haven't had any trig background, you're okay. You're gonna be learning along with everyone else, so no big deal. I have a couple problems, just some quick warm-ups. If you remember from geometry, I don't know how much you do remember, but the word trigonometry. Do you know where that word comes from? Trigonometry, by chance. Do you remember anything from a couple of years ago when we took geometry? What's that?
Triangle.
Okay, triangle's gonna be part of it, right? So it's split up into two words. So the trigon part is the triangle, and then the metric part is measure. So literally trigonometry is to talk about triangle measurement, okay? Yeah, that's where it comes from. And then these symbols here, we're gonna be seeing a lot of those in this class. There's some Greek letters. I don't know if you remember any of them. Does anyone know what the first one is? This one's the most common. One of the most common.
I feel like I should.
It's okay.
Fish.
Not fish. It's not the Greek letter fish. This is alpha.
Oh.
Okay, that's alpha.
Of course. Beta.
Yep, that's beta.
Gamma.
Okay, gamma.
And then that's theta, yeah.
Theta, yeah. Very good. So anytime, when we get to that point, we're not there yet, but anytime we see these symbols, we'll see theta a lot. You'll see it in this section. But anytime we're representing angles, we usually use Greek letters for it. Okay? Okay, not too bad there. Let's get started. Okay. First up, we gotta create an angle. So we need some parts to make that angle up. So quick little definition here. So we have a ray, which you learned from geometry, is a part of a line that consists of an endpoint and all points on the line to one side of the endpoint. So it's half a line, is what that's saying. So for a little example, just like a visual, which I'm more of a visual person, so I like seeing pictures instead of definitions. But this would be ray PQ, and the symbol that you put above it is just, well, half a line symbol, just like that. It does matter the order, okay? So I couldn't just call this ray QP. It has to be the endpoint first when you're naming these, okay? Now, if I have two of these rays intersecting, that's how we get the angle, okay? So let's talk about angles. Okay, so an angle is formed by rotating a ray about its endpoint. The starting position of the ray is called the terminal side. Oh, sorry, no. Read a little bit too far on my notes. Initial side, meant to say. The final position of the ray is called the terminal side. The common endpoint is called the vertex. Okay. And we'll just put a little nice visual here. Okay. Now, initial and terminal side, those are going to become pretty important. Okay. So here's just a basic angle that you've seen many times before. And I use theta to represent the measurement of that angle there. And then we can see that A is that common endpoint for both of those rings. Okay? So we know what angles look like. That's no big deal. Now, for this class, we're going to see angles. We're also going to see it in a different sense. So I'm going to draw another picture over here. So looking at an XY plane, we can draw an angle as well. Okay? So let's say this is my starting point. Right here, the x-axis, this is going to be my initial side. And then what I'm going to do is I'm going to take this initial side and rotate it a certain number of degrees. So let's say I rotated it over here. So from here to here, I rotated about 120 degrees. So this is my initial side where I started, where I ended up. This is my, we call it a terminal side. Okay? Now, if your initial side is at the x-axis here, and you're at the origin, okay, we call this the standard position. Okay, so if you see something like that where your initial side is the x-axis and you're using the origin as your common endpoint, we call it the standard position of an angle there. Okay? So we have two examples, one that's just a normal angle and one that's, well, on an XY plane that we're going to be seeing, a lot of them. Okay? Now, the measure of an angle quantifies the direction and amount, so direction and amount of rotation from its initial side to the terminal side. Okay? So that's how we define measurement of that angle. Okay, so how far would you go from where you started to where you ended? Now the other thing we're going to talk about is direction. Okay? Degree measurements are going to give me a direction of where I'm going in that XY plane. So let's talk about direction for a moment. If the rotation is clockwise, I'm going to use CW for clockwise. Measure of the angle is positive. So clockwise and positive there. Okay? So if you look at the example I just drew, that was a positive angle because I went in the wait a minute. Counterclockwise, I meant to put. Sorry about that. Counterclockwise. So counterclockwise, which is what I did over there, the angle is going to be positive. Now, if you rotate the other direction, clockwise, you're going to have a negative angle. Okay? So if the rotation is clockwise, I'll put CW. The measure is negative. So you can't have a negative angle, which is kind of weird, but that negative just tells you what direction you went in. Okay, so for example, I'll put two little examples underneath there. If the first example, I want to go 135, okay, and because it's positive, then it's going to end up somewhere over here in the second quadrant. Okay, so that's me going the counterclockwise rotation. Now if I have a negative angle, let's say negative 45 degrees. So I'm going clockwise, in this case, in this direction. This is still my initial side, I'm just going over here. Okay, so the negative just tells you the direction of rotation. Which, again, seems weird at first to have a negative angle, but it does actually have some meaning to it. Okay. All right, I'm just going to pause for a moment. Do we have any questions on that? just some basic definitions and just what those angles mean in terms of the XY plane and where you're rotating. Okay, moving on. Now, a degree can be broken up into parts. Okay, let's talk about that next. So let's talk about those parts. A degree can be divided into 60 equal parts, which we call minutes. Yeah, right. Which we could abbreviate as MIN or one little apostrophe. Okay? So a degree can be divvied up into 60 equal parts. And then, let's just say for an example, so 1 minute is 1 over 60 degrees. Or using another notation, should put that in parentheses too, actually. There we go. Or using the symbol, that apostrophe, 1 minute is 1 out of 60. Okay. So put it this way, this is where things get kind of weird, but we'll see in one of our examples we'll write it this way. So look at a clock for a moment. Okay, a clock is a circle, right? It's out of 360. So how many minutes are in a clock? 60, right? So a minute's 1 out of 60 degrees. Seconds, how many seconds do we have here?
360. Wait.
No.
Well, no, because there's 60 seconds in a minute, though. And
So 60 times 60.
3,600.
3,600, yeah. So
my bad.
3,600 seconds in a minute. So therefore, or I'm sorry, an hour right there. So therefore we have another measurement. So now we have a degree can be divided into 60 parts, but then we can take each minute, okay, can be divided into 60 equal parts that we call seconds, which we can abbreviate as SEC or 2 of those little marks, little prime marks there. So 1 second, okay, is 1 over 60 of a minute, or in other words, 1 over 3,600 degrees. Okay. Or what we could do is using the symbols, I can write it as 1 with those 2 apostrophes, 1 over 60 minutes, which is 1 over 3,600 degrees. Okay, so here's the deal. Here's what I'm doing here. I'm trying to represent a degree that has a decimal into something like this. Okay, so instead of me writing this as my decimal, I'll write it like this. Okay, it's just a different format of it. So let me put an example underneath it. So you could have 93 degrees, 30 minutes, 10 seconds is written as this. Okay? So again, looking at a clock is where we're getting some of these measurements from. Now, why do we do measurements like this? Well, remember latitude and longitude from your science classes and so forth?
Yeah.
Okay. Remember how they measure latitude and longitude? Okay, measure in degrees, right? Think of your time zones. So from how many degrees over and how many hours and minutes afterwards is you crossing to the next or it would be what? Longitude's this way, so latitude's this way. It'd be your next latitude line. Okay? So this is how we measure those latitude and longitude lines. So let's just go ahead and try an example out. So let's do, I think I got space here. So underneath here, let's convert to degrees, minutes, seconds. I'm going to abbreviate this from now on. It's DMS. Okay? So to convert a degree measurement to this, we'll say DMS. To degree decimal form. Okay, so let's say we had this 42 degrees, 13 minutes and 16 seconds. And what I want to do is I want to convert that to just a decimal value. 42 point what is it? Okay, using this information from above here. So 42 is the main value. This over here, not here. Hello? Okay. I do. I am. Yep, will do. Thanks, bye. Okay, so it's 42 point what? This is the decimal version. And we're gonna figure out what that decimal part of the value is. Bless you. So let's do that. So 42 plus, now 13, okay, so think about it, it's 13 minutes. So each minute would be 1 out of 60 degrees here. So it'd be 13 times 1 over 60. Okay. Plus, and then we have 16 seconds. So it'd be 16 times 1 over 3,600. Okay. Now, just to show some units, this is in minutes, okay? And this is in minutes over a degree. This is in seconds. This is seconds over a degree. So unit-wise, the minutes will cancel out, the seconds will cancel out, and all you have is degrees left. So now all you have to do is, well, type it all in your calculator. Okay, so if I do 42 plus be 13 over 60 plus 16 over 3,600, you get the following. So it'd be 42 plus 0.216, it does repeat, plus 0.0044. So I'm just writing the values underneath it. That way, when you get a chance to, you can look in your calculator and see if you match up to mine. And when you add them all together, you get 42.22, we're gonna say 1 degrees. Rounding it to 3 decimal places. So in other words, this is what this is representing. Okay? Any questions? Now we're gonna go backwards. Okay, what if I had this? Can we go back to degrees, minutes, and seconds? Okay, I'm gonna put on that board over there. Okay, so we're gonna try converting from decimal degrees to DMS form. Okay. And we're gonna try doing it with this. 275.33 degrees. So we're gonna rewrite that in, so it's gonna be 275 plus how many minutes plus how many seconds? So here we go. So you start with 275, that's your whole number, okay? Just like over here, whatever the whole number was, that's what you start with. Okay, plus, so I'm gonna take this and convert that part of the decimal into minutes. So it's gonna be 0.33, okay, times, so it's gonna be your 1 over 60. Actually, I'm sorry, we're going backwards here. I should meant to say 61. Now when you multiply those together, okay, this is gonna have some decimal amount afterwards. So this is what's gonna be. It's gonna be 275 plus, okay, 19.8 when you multiply them together. This is now gonna be what you're gonna use to find your seconds, okay? So let's go ahead and rewrite this. So this is gonna be 275 plus 19 minutes. Now to get your seconds, we're gonna do the same thing. Now because this is already minutes, I don't have to multiply this by 3,600. It's already minutes, so you need just 60, because 60 seconds in each minute. So it'd be 0.8 times 60 over 1. Because again, that 0.8 is part of the minutes, so I don't have to multiply by the 3,600. Okay, so we get 275 degrees, the 19 minutes, and this becomes 48 when you multiply. So your final answer, we'll write them all together without the plus signs. So it'd be 275 degrees, 19 minutes, and 48 seconds. That's what that decimal value would convert to. So again, if you're converting from this to DMS, you're multiplying your decimal values by just 60, because you're going from degrees to seconds. Over here, okay, if I'm going backwards, so then each one of these I have to take into consideration. That's your minutes, so there's 60 of them. These are your seconds, so it's 3,600. Okay, so that's another way of rewriting some angle measurements. Like I said, it works well with latitude and longitude. Okay, so now, that's degrees. We can also measure an angle in radians. Let's talk about radians next. Okay. So, what is a radian? Okay. And in math, we like radians. Okay, bless you. You'll see that radians have no units to it. Okay. Angles are measured in degrees. Degrees is a unit. So a lot of times in mathematics, especially in calc, and even in physics, we like to have things that are a radian measure, something that didn't have a unit attached to it. So let me just draw you a quick picture. Okay, so a little picture right there. So I have a circle there, there's my radius r. So I have my angle will be angle BAC. And theta is just the measurement of that angle, okay? So, we define 1 radian, which we can abbreviate to rad, R-A-D, okay? To be the measure of an angle subtended by an arc equal to the length of the radius. Okay. In other words, look at my radius. I want to know how many of those fit in the angle. That's what a radian is. Okay? So for instance, if I take this radius right here, I want to figure out how many of those fit in this space. And that's what we call a radian. Okay? So instead of an angle measurement, we figure out how many radii can fit into there. Okay? Any questions on that? Does that make sense? Okay. So how do we find the radian measure of this? Well, it's pretty simple. I already said we had to figure out how many radii fit into it. So let's use that. Okay. We can find the radian measure of any central angle by dividing the length of the subtended arc by our radius r. So, in other words, theta is equal to s over r, where theta is in radians. Okay? That's a weird theta. Let me make that a little bit better. So that's what it's telling me, just how many of those fit inside of there. Now S, I'll put down here, S is the length of the arc. Okay, so from here to here, how far did we travel? And then we already know what R is, but I'll put it down anyway. R is our radius for that guy. Now, what we can do, we can actually make another formula here. If I want to know what the arc length of that guy is in radians, I could solve this for S, which is pretty easy. Just multiply both sides by R. So you could rewrite this as S equals R theta. Okay, and that's if theta is in radians. Okay, this will tell us the arc length. So here's another formula. Okay, so if I want to know the arc length from B to C, I do the radius times the angle, which is in radians. Okay. So far, so good. Let's break that down a little bit more. Okay? So let's take a look here. So a full circle which is just one big arc, is measured by the circumference. If I can spell circumference, let's see. There we go. Which is 2 pi r. Okay? So let's think about it. So full circle, the full arc is your circumference, that's 2 pi r. Okay. So if that's the full arc, if I were to plug into here, I could figure out how many radians a full circle is going to be. Okay? So let's do that. So over here, okay, so theta is S over r. So my arc is the whole circumference, which is 2 pi r. I'm going to divide it by the radius, which is just r. We can see those cancel out. So it would be 2 pi radians. Okay? So that's one full revolution, or in other words, full circle. Okay? If you go around the full circle, it's exactly 2 pi radians. And if you want to put the decimal value, I'll put underneath it. That's roughly 6.28. Okay? So it's like 6 and some change radii could go around that full entire circle there. Okay? Now, we can go a little further with it. Since we know what the full circle is, radian-wise, I could break the circle up into different parts. Okay? So let's do that. So let's say I want a half of a revolution. Okay, so let's say I just go half. So if the full revolution is 2 pi, what would half a revolution be? Just pi, right? Half of it. So from here to here, okay, we'll take our full revolution divided by 2, we get pi. So this whole thing is pi radians. What would that be as a degree measurement, do you think? 180, right? So I'll put underneath here, okay, also, that's 180 degrees. Okay? So there's pi radians of a semicircle. Okay? Let's do a fourth of a revolution and see how many radians that would be. So that would be this guy right here. So we got a fourth. So if I know the full thing's 2 pi, I'm cutting in fourths, so we'll just do 2 pi divided by 4, okay, which would be pi over 2 radians. So this will be pi over 2. Now, what would that be in degrees? That's an easy one, right? 90, yeah, 90 degrees. Here we go. Okay, let me just pause for a moment. Any questions on how I'm getting those values? We okay with that so far? Okay. So now, what if I did 3/4 of a revolution? So that's, boom, all the way to there. Okay. Well, we do the same thing, right? I'm going to take 2 pi. We're going to take 3/4 of it, and we get 3 pi over 2 radians. Kind of running out of space there.
Because it's 6 pi over 4.
Now, let me ask you this. If it is 3/4, how many degrees would that be? What do you think? 270, right? Because this is 90, that's 180. So another 90 is 270, so I'll put 270 degrees here.
I forgot.
Okay,
I do enough trick shots.
so there we go.
Why? Oh.
So let's think about something for a moment. We we know what these are degree-wise. That's not an issue. Now we convert it to radians, which remember, radians is how many of those radii can fit into there. Okay. By the way, if they don't write the word radians, we assume it's radians. Okay. If it's not radians, they'll have a degree symbol. So you might not see radians written a lot of times. They might just leave it as pi over 2. So as a quick summary, okay, let's put this right here. So at the very top here, we got pi over 2, which is 90 degrees. Okay. Here would be 0 to start, but when we go the full way around, it'd be 2 pi radians. So that'd be 360. So this one has 3 things, because like I said, you start at 0 degrees, you go the full 360, and 360 in radians is 2 pi. Over here, we said this is 180, which is just pi. Down here is 270, which is 3 pi over 2 radians. Okay? And remember, they're unitless. There's no units to it. It's not feet, it's not inches, it's not degrees. It's just a unit that we can use to represent an angle. Okay? All right, any questions on that? Now this is important. You're going to see this a lot in this class. Okay? Now, let's try converting from degrees to radians and radians to degrees. Okay. So to convert from degrees to radians, okay, you're going to multiply by, now let's think about something for a moment, okay? We have some pretty good conversions on that summary table over there, okay? We already know that 180 is the same thing as pi radians. Now we know that 270 is 3 pi over 2 and so forth. I want to pick the one that's probably easiest to work with, which would be the 180 in pi, okay? So if I want to convert from degrees to radians, I'm going to multiply by pi over 180. To convert from radians to degrees, if you flip it, well, you're going to multiply by 180 over pi. Okay? So you're just flipping the fraction itself. Now again, I could have used 2 pi and 360, but those are some higher values. Pi over 2 and 90, you're messing with a fraction there. Fraction of fraction, same thing with 270. So it's just a little easier to work with 180 and pi. Let's try an example. Convert from degrees to radians. So I got 2 little angle measurements that we're going to do that for. So for the first one, I'll take the 150, okay? And looking at what I just wrote up above, to go from degrees to radians, I'm going to multiply by pi over 180. Okay. Now the reason why this converts to radians, look at what's happening here. You have a degree measurement on top, degree measurement on the bottom. Those degree units are going to cancel out. So this becomes unitless, which is what radians are. So this becomes 150 pi over 180. And if you can reduce, you want to reduce. Okay? And this does reduce. This reduces down to 5 pi over 6. And again, you don't have to write the word radians. It's understood that it is a radian measurement. If you want to put RAD, you can do that as well. Okay? All right, now part B. Even though it's negative, that's okay. You're going to do the same process. The negative really doesn't do anything. I mean, we know it changes the direction of your rotation, but in terms of converting, it does nothing. So we're going to multiply it by pi over 180 degrees. We'll just keep the negative when we multiply through. So negative 45 pi over 180, which reduces to negative pi over 4. Okay. Now if you want to, I mean, let me just draw a picture underneath it. So 150 would be like roughly over here, you'd say, right? Something like that. So from here to here, that's 150 degrees, or 5 pi over 6. So we have 2 measurements for that angle. On this side, negative 45 degrees, well, that's going to go in this direction. So we're going to say roughly here. So it's either negative 45 degrees or negative pi over 4. So just showing like a nice little visual of what we just found. Okay. All right. Any questions on that? Sound good? A little bit of converting? Like I said, you could have changed this. You could have made this like 2 pi over 360. I mean, that works too, but just your numbers are a little bit bigger. Okay, let's go backwards. Well, not backwards, I should say, the other direction. Let's see. We're going to convert from radians to degrees. Which honestly isn't a bad thing. If you have a radian measure and you want to know what it looks like, it's kind of hard to work with radians to figure out what it's measured to. It'll get easier as the year goes on because we'll be doing a lot with it. But sometimes it's nice to convert to degrees to get like a nice visual picture. So we're going to have 3 pi over 4. We're going to see what that looks like. And then we'll do negative pi over 3. See what that looks like as a negative degree measurement. Okay, so for this one, we got 3 pi over 4. I'm going to multiply it by 180 over pi. And again, just kind of sticking with it. We can see that the radian measurement, radian and radians, they're going to cancel out. We're just going to be left with degrees, which is nice. Okay. So, pi's are going to cancel out, which is good. 3 times 180 divided by 4 comes out to be a nice number. It's 135 degrees. So 3 pi over 4 is 135. So if you want to, we could draw a little picture underneath it. That's going to be, I mean, we're guessing, but I'd say somewhere here. This is 135 degrees, which is 3 pi over 4. Just like that. Okay, part B, just like the part B over there, that negative isn't going to affect anything. Just convert normally. So negative pi over 3 times the 180 over pi. Okay. Again, we can see that we're just going to have degrees as a result. Pi's are going to reduce out, so they're gone. We just get, well, 180 divided by 3, which is negative 60. Negative 60 degrees. So that means I'm going to go in this direction, clockwise. Actually, that's more 45, huh? Let's say 60 is here. Try to be a little bit accurate with it. So negative 60 degrees, which is the same as negative pi over 3. Okay. Alrighty. So hey, 2 measurements to define an angle. Is there 3? No, that's the only 2 ways. Okay, that's it. Degree measurements and radian measurements. That's all we got. Any questions on radian measurements? We okay with radians? Yep.
They seem fine from what I picked up.
Yeah, I get it.
Okay.
I was a little lost for a second, but I'm like, oh wait, I'm just.
Good, good, good. All right. Definition.
It's like degrees in terms of circle.
2 angles and standard position. No, we're not done yet.
No, we're close.
Of course we're not.
With the same initial side and same terminal side are called coterminal angles. Okay. And again, we're going to draw a picture underneath this so you can kind of see what the definition is saying here. But what it's specifically talking about is, what if you have an angle, and then if you rotate it 360, you arrive at the same position. So that angle and the angle you started with are pretty much called coterminal angles. They're going to have the same values for that. So for example, let me just draw this underneath it. Let's say you had 30 degrees. Okay? Well, if I take that 30 and rotate it a full 360, So I get back, that's gonna be what, 390 degrees? And would that get me back to where I started? Absolutely, right? Okay, so we call this coterminal, where they have the same initial side and they end in the same spot. So it's you essentially adding 360 to it. And could you go further with it? Yeah. Could you rotate another 360 and arrive at the same spot? Yeah, you can go on forever that way. So there's a bunch of coterminal angles with 30 degrees. Okay, so let's try that out. So example, find an angle, coterminal to theta between 0 degrees and 360 degrees. Okay, so let's do 780 degrees as one of our examples. Okay, and the other example we'll do negative 270. That way we can kind of see what to do with a negative angle measurement. Okay. So 780. I'm going around the circle a couple times, huh, to achieve that. So we want to know if I were to have a smaller angle between 0 and 360, is there a smaller angle that is at the same position that the 780 ends on? Okay, something like this, like 30 degrees ends in the same position as 390. So all I'm going to do is take multiples of 360 away from this guy until I get that angle that's between 0 and 360 that ends in the same spot. So let's do that. So we can do 780. Let's minus 1 full rotation. Okay. So let's go ahead and subtract 1 full rotation. We get 420 degrees. Now, 420 degrees ends at the same spot as 780. They're coterminal, but is it between 0 and 360? Not yet, right? So we gotta subtract another 360. So 420 minus another 360. And we get 60 degrees. There we go. So 60, which would be somewhere here, okay, and then 780, which we would be going around a lot, okay, at least twice, a little bit more than twice. We arrive right here at the same spot at 60 degrees. Hello? Uh-huh. Okay. Uh-huh. Bye. Guidance is killing me today. Okay. Any questions on how we found that coterminal angle? We okay with what it means too? Like where they're both ending at the same spots? Okay. Now negative 270, still the same thing, except I'm not going to be taking away 360, right? I'm going to be adding 360 to figure out what angle ends in the same spot between 0 and 360. So this way, negative 270 degrees. We only have to add 360 once to have it work. If it was like negative 700, I have to add 360 twice to get to that point. And we get that to be 90 degrees. Okay, so 90 and negative 270 end at the same spot. Now let's look at the same situation but with radians. Okay, let's see if we can do that. So we're going to find an angle, coterminal to theta on the interval 0 to 2 pi. So I'm doing the same thing from like 0 to 360, but I wrote an interval notation and wrote it in radians, right? So let's try negative 7 pi over 4 as one of my examples. And over here we'll do 15 pi over 2. All right, for the first one, because it's negative, I'm going to be adding 360 to it. So what's 360 as a radian measure? What did we say? 360 is the same as what? 2 pi, right? Yeah. Okay, so I'm going to be adding 2 pi to that. So let's do that. So negative 7 pi over 4 plus 2 pi. And common denominators, so we'll do that real quick. So it'll be the same as 8 pi over 4. And when I add them together, I get pi over 4, which is between 0 and 2 pi, right? So we're good. So pi over 4 and negative 7 pi over 4 are in the same positions there. Okay, 15 pi over 2. So let's think about something for a moment. Okay, if I were to divide those together, if I divide them, I get 4 and a half. Well, not 4 and a half, wait a minute. Don't want to go that direction with me, hold on. Let's do this instead, actually. I think it loads too far ahead. I want to figure out, because 15 over 2 pi is bigger than 2 pi, right? Way bigger than 2 pi, okay? It's like, what, 7.5 pi. So I already know it's one of these larger angles. So I gotta take away 2 pi in multiple increments. Now what you could do to figure out how many 2 pi's you're taking away from it, you can take 2 pi and divide it into here and see how many times it goes around, okay? So it's one method of trying it out. So if I take 15 pi over 2, okay, and divide it by 2 pi, and see what I get at the very end, that's gonna tell me how many multiples of 2 pi I'm gonna take away from it. So this becomes 15 pi over 2, okay? We'll multiply that. So this, if I rewrite it as a fraction, I'll put in parentheses. That's gonna be the same thing as 4 pi over 2. Okay, so that just becomes 15 over 2 times 2 over 4 pi. That gives us 15 over 4, okay, which would end up being 3 3/4 of a revolution. So you're going to go around, what, 3 times? That's what that's telling you. So I'm going to be subtracting 2 pi 3 times to get that coterminal angle. So let's do that. So now that we have how many times we're doing it, we can actually do it exactly. By the way, could you just start subtracting 2 pi and just see what happens? Absolutely. Okay, you don't have to do this extra step if you don't want to. So 15 over 2 pi minus 3 of those, it'd be 4 pi over 2. I mean, it's minus 3 2 pi's, but I'm going to go ahead and write as a fraction that we can work with. Okay, and we get 3 pi over 2 as the final answer.